We're surrounded by this colossal, invisible source of energy. It's being generated right now by everything from giant data centers to cement factories. In this explainer, we're going to go on a hunt for this hidden power and figure out how we can turn the energy we're literally throwing away into the warmth that heats our communities.
Just stop and think about that for a second. Every factory, every whirring server, every big building is constantly leaking energy. What if, instead of just letting all that heat disappear into thin air, we could actually capture it and put it to good use? And this isn't some far-off fantasy. It's about seeing waste not as a problem, but as one of the biggest untapped resources we have.
All right, so first things first. Before we go any further, let's define what we're actually talking about. What is this invisible energy that we're losing all the time?
It's called waste heat. And the definition is actually beautifully simple. It's the heat that's produced by, well, almost anything that doesn't get used for its main purpose and just escapes. It's literally the warmth coming off the back of your fridge, but just imagine that on a massive industrial scale.
Now, here's where it gets really interesting. The usefulness of all this waste heat really depends on one thing: how hot it is. Because, not all heat is created equal. You can't do the same things with lukewarm water that you can with superheated steam. So, to make sense of it all, experts kind of grade it.
It basically breaks down into three main buckets. You've got high-grade heat, which is over 400 degrees Celsius. Think of the inside of a cement kiln. Seriously hot stuff. Then there's medium grade, maybe from an industrial boiler, and then you have low-grade heat, anything under 100 Celsius. It's the most common by far, and while it might be too cool for a lot of industrial jobs, it turns out it's absolutely perfect for heating our homes and businesses. Okay, so if this heat is pretty much everywhere, where do we actually start looking? Well, the hunt for these sources can lead you to some really surprising places.
And just look at this list. It really shows you how diverse these sources are. Yeah, you've got the obvious heavy hitters like cement production, but also things like data centers and even supermarkets. All of them are just constantly pumping out this low-temperature heat we could be capturing. But there's one source on this list that's, well, it's just plain fascinating.
That's right, flooded, abandoned coal mines, the very symbols of an old industrial era. See, as these mines filled up with groundwater over the decades, the natural heat from the surrounding rocks has been gently and constantly warming up that water. They've basically turned into these massive underground thermal batteries.
So what's the magic number here? Well, if you go down about a kilometer, that mine water can reach a steady 40 degrees Celsius. And the key word there is steady. It's a consistent, year-round supply of low-grade heat, just sitting there, waiting for us to use it. And listen, this isn't just theory, it's already happening. Take the Gateshead project in the northeast of England. It's a perfect real-world example. They're literally pumping this warm water from 150 meters below ground to supply a heat network for hundreds of homes and buildings in the area.
And the impact? It's honestly staggering. This one project alone is expected to save 72,000 tons of CO2 over its lifetime. It's just a powerful example of turning an industrial relic into a clean energy asset for the future.
Okay, so we found the heat. That's step one. But the next big question is, how do we actually, grab it and put it to work? For that, we need a special kind of toolkit.
When you break it down, there are really three main things we can do with it. We can use it directly as heat, which is the simplest way. We can convert it into electricity, and this is the really clever part, we can actually upgrade its temperature to make it even more useful.
So tool number one, and this is really the workhorse of the whole operation, the heat exchanger. The concept is super simple. It lets heat move from one liquid or gas to another without them ever physically mixing. Just imagine two pipes running side by side, one hot and one cold, and the heat just passes right through the pipe walls. That's the basic idea.
And they come in all shapes and sizes, like these plate or shell and tube types you see here. Each one is designed for a specific job, which makes them incredibly versatile.
All right, tool number two. Now, if your waste heat is hot enough, you can do something even more transformative with it. You can actually generate electricity. We're talking about turning heat straight into power.
There are two main ways to pull this off. You've got the classic method, the steam Rankine cycle. It needs that really high-grade heat to boil water and create steam to spin a turbine. But then you have its more flexible cousin, the organic Rankine cycle, or ORC. This one's a bit of a game changer because it uses fluids that boil at a much lower temperature, so it can make electricity from much cooler sources.
But what about all that low-grade heat we talked about? The stuff that's just not hot enough to make electricity? Well, that's where our third tool comes in, and honestly, it's amazing. I'm talking about the heat pump.
This is the tech that makes lukewarm water incredibly valuable.
The easiest way to think about it? It's basically a refrigerator working in reverse. Seriously. Your fridge works by pulling heat out of the inside to keep it cool. A heat pump does the opposite. It pulls heat from a source, like that mine water we mentioned, and concentrates it to make it even hotter.
And this is why they're so incredible. Just look at these efficiency numbers. A water source heat pump can be up to 400% efficient. Now, I know that sounds like magic, but what it means is, for every 1 unit of electricity you put in to run it, you get 4 units of heat energy out. It's not creating energy from nothing. It's just insanely good at moving it from one place to another.
Okay, so this all sounds amazing, right? But of course, tapping into all this heat isn't a walk in the park. There are definitely some hurdles, so it's important to look at the real-world pros and cons here.
On the one hand, the opportunities are massive. I mean, we're talking lower energy bills, a much smaller carbon footprint, and even a new way for businesses to make money from their waste. But on the other hand, the challenges are very real. These projects can have high upfront costs, you obviously need a customer for the heat nearby, and the installation itself can be a big job. It's a classic cost-benefit trade-off. So, that brings us full circle. The energy is there. It's flowing invisibly all around us, from our industries, our infrastructure, and even from the ground right under our feet. We have the technology. We know how to capture it, move it, and upgrade it. The question isn't, can we do this anymore? The real question is, what's it going to take to finally connect all these millions of scattered sources to the millions of homes and businesses that need the warmth?